Well, this video is regarding the details of the network layer, and here we are going to see the routing algorithms because they form the very important component of the routers which comes under the network layer. And so many routing algorithms are used. Just for the sake of introduction, they use shortest path, flooding, flow-based, distance vector, link state, hierarchical, broadcast, multicast, or routing for mobile hosts. And the main important function of the network layer is the congestion control. If there is a good intelligence built into the router, then the congestion can be controlled over the network because the subnets can be properly used for the controlling the congestion so that the traffic can be directed only to the intended receiver. IP addressing is yet another important function of the network layer, because as we have seen that on the computer network, all the hosts or all the nodes, they are identified and there is an addressing scheme that exists which is called as IP addressing. Apart from that, every node has got sub address called as MAC address. And we'll see the details of the routers. So basically, the routing algorithm are concerned, the most important aspect of any routing algorithm is the shortest path, and they can be better expressed by means of graph theory. Here you can see that these are the possible nodes: node A, node B, node C, node D, E, F, and so on, right? And the main function which is used, the main principle which is used in case of routing algorithm is the shortest path from the transmitter to receiver. Another important aspect of the routing algorithm is flooding. So in order to prevent packets from circulating indefinitely, a packet has got hop counter. You must have seen, if you use a command called as trace route, then these hops you can see from the transmitter to receiver. So there are certain number of hops and there is a hop counter. After that hop counter exhausts, then the packet is dropped from the network so that the packet is prevented from moving indefinitely over the network. If the packet is made to move indefinitely over the network, then there is a possibility of congestion, and then the entire network can come to standstill. So every time a packet arrives at for example at an IMP, the hop counter is decreased by 1, and once the hop counter of a counter reaches to 0, the packet is discarded over the network. So by using this principle of hop counter, the congestion over the network is avoided, and this is the main function of the network layer. As far as the IP addressing of the network layer, which is mainly concerned with the network layer, is concerned, there is a format for the IP addressing. So here you can see that this is the format which is shown on the screen. So in this way, it can be either 0 or 1. So generally it is expressed something like this. For example, given in the example 1, this corresponds to 255, this corresponds to again 255, this corresponds to 0, and this corresponds to 0. So the IP address becomes 255.255.0.0. Here also you can see, if this kind of scheme is there, then it is 255.255.192 to 0. So basically these schemes are used for IP addressing. So this corresponds to decimal octet scheme, which is used in case of the IP addressing. Now how the network addressing is done basically. So any IP address of the computer, for instance, if the IP address of the computer, the node which is connected to the network, is 180.100.7.1, then a mask is used. The mask is always 255.255.0.0. So if you do this masking operation, which is essentially the ANDing operation, then the network address you get is 180.100.0.0. Let's take the second example. If the IP address is 180.100.7.1, if the mask is 255.255.255.0, then you get the network address called as 180.100.7.0. Yet another example you can see in 3. If the IP address of the computer is 180.100.7.2 and the mask is 255.255.192.0, then the network address you get is 180.100.0.0. So in this way, depending on the mask, you get the network address of the computer. So the network address is the address to which the host belongs to. So that is calculated on the basis of masking operation, which is essentially the ending operation. Now here you can see the valid masks are contiguous ones from left to 0. So here you can see the valid and invalid examples of the masking. So the valid masks are something like this: 255.0.0.0 or 255.255.0.0, or it could be even 255.255.255.0. While the invalid masks, they differ because they are not contiguous ones from left to right. So 255.1.0.0 is an example of the invalid mask, because there is no 255 here, it is 1. And here also you can see, even it is 255s in this particular format, but there exists 0 in between, so it's invalid. So third example is also invalid because it doesn't have the ones, the required number of ones. So these are the examples of the valid and invalid masks, and they basically decide the network address. Now, another important aspect of the network layer is the subnets. Because why subnets are used? Because there is a limitation, because internet is now flooding with the number of nodes, and they use a system IPv4, or now they use a system called as IPv6. But even with that, the internet is running out of IP addresses because it is spreading in every nook and corner of the globe. So if you want to go away with the exhausting number of exhausting IP addresses, then one can use a solution called as subnets. And this subnets is one solution for giving network address. So how this subnet works? So subnetting is done by borrowing the host bits, which can be used as the network bits. So for instance, the class B mask is 255.255.0.0. So borrowing one bit gives a subnet mask of 255.255.128.0. Or borrowing 2 bit, it gives, here you can see that this particular octet is changing, so it will be 192.0. Or if you use 3 bits, then it becomes 224. If you use 4 bits, then it becomes 240. So the subnet mask becomes 255.255.240.0 in case you borrow the 4 bits. So I would like to give an example how the IP addressing is used. So given an IP address, suppose the IP address of a machine is 180.200.0.0. This is subnet by borrowing 4 bits. So this becomes, the subnet mask becomes, if you don't borrow, then it becomes 255.255.0.0. If you borrow 4 bits, it becomes 255.255.240.0. The 4 bits borrowed are value 128 or 64 or 32 or 16. So this will create a 16 subnetworks. So here you can see this is the subnet mask, and if you use this borrowing, then there are possibilities like 128 or 64 or 32 or 16, and then the subnetwork address. Subnetwork is the part of the network. The address becomes 180.200.0.0, or it can become, if you just borrow 4 bits, it becomes either 180.200.16.0, or it becomes 180.200.32.0, or 180.200.48.0, depending on which ones you are changing. So in this way, there exist 16 possibilities by borrowing ones. And for example, for the subnetwork 180.200.16.0, the valid IP addresses will be from the range, because here you have the liberty to change the bits, and it becomes 180 to 180.200.16.1 to 180.200.31.254. In this way, there exist lot of possibilities by borrowing the ones in that particular octet. So these are some examples of this. And the router is basically a device which is typically used in the network layer, and it's called as layer 3 device, and that is used to interconnect two or more logical networks. So there is one network on left hand side and there is another network on right hand side. So if you want to connect these two networks, then you can use router. And this router can filter the broadcast traffic, and it prevents broadcast traffic from one network from reaching to another network. So that is the main essence of the operation of the router. So in this way, we have seen the details of physical layer and network layer, and the devices corresponding to these layers, and this forms a very important part of the hardware of the computer network. Thank you very much.